Thanks, Michael and Shruti. Well, that was magic. It almost looks so simple, but I guess that's the power of AI. What you saw was roughly 2 days of work in 15 minutes. Now, if you're like me, you're probably doing the math on that and saying, wait a minute, is he saying AI will be, 60 times faster? I'm not quite saying that. I want to be clear. But maybe for the old NI customers, 10x for test should be back. So, what you saw was expert-led every step of the way, with Shruti coming in there and being able to audit it. It was AI enhanced as we brought it to our tools. And of course, all the tools we use behind the scenes were industry ready. This is just the beginning potential of AI for improving your productivity analysis as a test expert. We believe in our vision of intelligent test. We believe it will transform the way you bring products to market. But before we go, I got one more thing. I'm an engineer at heart, and I'm still wondering, why was that only 32 dB? One of my favorite things was going to a whiteboard and trying to solve problems of the unknown. Why? What if? What could we do? Could AI be that partner? Well, in the final demo of 2023, Alejandro Barreto, he gave you an early preview of AI chatbot called Nigel. Well, Nigel keeps advancing. You saw it yesterday in the preview, but Nigel even has more skills than you've seen. So I'd like to show you Alejandro exploring the idea of AI emulating the at the whiteboard experience.
Well, let's explore this idea together. So I've loaded up the data that Shruti ran on stage. It is the small signal gain for our amplifier. We're characterizing the performance and the test limit for this amplifier. And I'm wondering, can we do better? I see this faint line here. I'm just going to draw this arrow here, say, hey, Nigel, why is this so low? And just a heads up, we're going to speed up this video in the interest of time, but everything you're seeing here is real. Okay, great. Looks like the AI replied, and it's telling me that this faint curve could be because of a variety of factors, such as variability in the DUT performance or measurement errors, perhaps at the test station, and that this curve is actually potentially bringing down my limits. And it's telling me that to further investigate, it might be useful to examine the distribution of small signal gain values more closely. So let's do that. Okay, well, the AI replied with a distribution of small signal gain around that frequency, 8.5 gigahertz. And I see here this distribution is bimodal. So I'm just wondering, I'm just going to circle these samples here and ask Nigel, examine why these samples exist. Awesome. Well, it looks like Nigel created a distribution here of the small signal gain around the frequency that I had placed my arrow. And it's giving me some statistics. But what's interesting are these observations here. So it's saying here that all of the samples come from the same test station, TS002, which might suggest a station-specific issue. And that furthermore, there are 25 different DUTs in these samples. And that might indicate that the issue is not isolated to a specific device, but could actually really be the test setup or the conditions at the station. And it's suggesting that we should examine this station. Let's ask the AI to plot the gains for all test stations for all frequencies. Great. So it looks like the AI created a chart here plotting the gains across all test stations at all frequencies. And we can see here that test station 2 is definitely lower for all the measurements. So something must be off about this test station. Perhaps it's a loose cable. We're going to have to investigate that. But for now, let's just ask Nigel to redo the first chart with the test limits, but without TS002, and show me the improvements in the performance and limits in a table, if any. Awesome. So it looks like excluding the bad test station led to a 1 dB increase in the amplifier's gain. The typical performance now rounds up to 33 dB, and that's a better number that we can include in the data sheet. This more precise characterization of the gain is a big deal in RF applications where every decibel counts. So what we just saw was that the AI analyzed our measurement data, crunched some numbers, and helped us diagnose an issue at the test station, all of which led to a better characterization of the device, which I know your customers will love, all without breaking a sweat.
Pretty incredible. AI can even find a loose cable. So that was a video of Alejandro. But if you want to see him live and in person, at 1:30 today, he's in the Ask the Expert section. If you want to see how we did that and how we do other things, go there and ask him some questions. It's incredible to see where intelligent test can go. We've shown you today is really focused on the user and the enterprise aspects of it. But this is just a portion of our research. We're exploring far broader capabilities of intelligent test. We're looking at instrument intelligence and how we can adjust decisions dynamically based on device-specific data. We're extracting features through embedded waveform intelligence, and we're improving design through simulation and digital twins. These give you an idea of the broader impacts this technology can have from engineer to enterprise. So whether you're working on the latest smartphone chipset or the next generation of medical devices, intelligent test will disrupt your market. The future of test is exciting, and we're building it faster than ever, one innovation at a time. Thank you. Enjoy the rest of NI Connect.